Hello. Today we are going to talk about managing files and file naming. It is important to take some time to plan file and folder structures and naming procedures in the beginning of your research. You need to think about organizing your data files into well-structured folders to be able to locate and use your research data files efficiently. You should agree on this within your project from the very start of data collection or creation. Descriptive file names are an important part of organizing, finding, and keeping track of your data files and their versions. The Data Management Plan is a document which defines how data is processed during the research project and after the project has ended. This includes, for example, instructions for creating descriptive metadata, information about file formats, plans for version control, backups, and other practical data management, policies for rights and access, sharing and reuse, and so on. Use the existing data management plans in your organizations directly or create your own plan. It is also good practice to document your file naming convention from the start. This helps you create coherent practices and manage versions and processes. You can do this by creating a README file in the dataset root directory or by describing this in your data management plan. In this way, also others can understand your file naming rules.
First, think about your dataset. What kinds of files and file formats will it include? What are the essential keywords and what is the context? How do you want to sort and search your files? Using just enough contextual metadata in file names and in right order, you are able to make it easier to sort and find your files later. Usually and by default, the computer systems show the file names in alphabetical order. Also, especially in a graphical user environment, long file names tend to be shortened so that the user is able to see only the beginning of the file name. Therefore, set the most important information first. If your data is based on a time period, it may be a good practice to use dates in the file names. If this is the case, then ISO standardized dates should be used to make chronological sorting easy. The dates are then expressed in year, month, day order. Also, it is a good practice to have unique file names within the dataset. Determine the delimiter you want to use to separate different elements in your file name. But be careful, as different operating systems handle special characters differently, including punctuation marks, spaces, and Scandinavian characters. Avoid those, as there may be re-encoding needs for these characters in certain environments or interfaces. In general, it is quite safe to use dashes or underscores in file names, and these are usually used as delimiters or instead of spaces. It is a good practice to use only characters from A to Z, numbers, dashes, and underscores. In that way, you will not run into interoperability problems. You may choose to keep your file name length quite short, for example, below 25 characters, or aim to keep it, for example, between 40 and 50 characters. Sometimes this depends on your directory structure or the context of the dataset. It is important to have just enough information in your file names for convenience, but avoid using exceptionally long file names because there exists maximum limit in the full file path length in some operating systems. Also keep in mind that in some operating systems, the file names are case sensitive and in others they are not. There are various options to use versioning to track your changes. This can be done simply in file naming or for advanced use with a version control system. In file naming, for example, a date or a version number can be used. If you use a date as a version, you should use the ISO standardized date format in year, month, day order. Another way for versioning is to use version number. Here you might want to use 3 or 4 leading zeros. This also makes sorting unambitious, as in computer system, leading zeros are sorted before other numbers. Avoid using, for example, words new or final, as then you will run into problems with the next version. In case you are in the need of tracking your changes or collaboratively editing files with your colleagues, the versioning can be handled automatically. For this purpose, you might want to look for some version control system or document management system. Version control systems are used especially when creating common software code with others. Use the same conventions in directory naming as with the file naming. Special characters have the same issues with directory names as with the file names. Avoid creating deep, complex, or detailed directory structures, otherwise the directory structure will become very difficult to maintain. On the other hand, file listing may become very slow if there are several thousands of files in the same directory. Try to create a structure which, on the other hand, is quite flat, but on the other hand, clearly separates different kinds of data from each other and does not result in thousands of files being accumulated to a single directory. Use your research field's instructions and guidelines for the directory structure, if those exist. One example of such structure is brain imaging data structure, BIDS, which has been created by the scientific community of brain researchers. It defines the file formats, file naming rules, and rules to organize the data in directories. If common guidelines are missing, you may consider the physical or logical structure of your data and try to model it to your directory structure. In the slides, there is an example of a logical structure containing the following directories: source material, outcome material, publications, documentation, configuration files, method descriptions, and rights statements. Additionally, it contains a README file where some useful information is explained to get started, for example, short descriptions of the contents of these directories. Using some basic metadata in your directory names may help yourself for searching, browsing, and sorting your data, but it is not a very interoperable method. For example, if you share a single file from your dataset to another party, then the other party has only that single file and cannot see your directory structure and the included metadata. Write the metadata of your dataset in a separate README file and share this information with others who are using your datasets.
In an object storage system, the data are stored as objects in buckets. In general, objects are similar to files, and a bucket functions similarly to a file system directory, except that there can only be one level. In other words, buckets cannot contain other buckets. A bucket is a container for objects that may also include metadata describing the bucket and objects. The stored objects can be of any data type, such as images or compressed data files. A bucket is a data object container and should not be confused with Dockers or other computing containers. Each bucket must have a name that is unique across the whole service. All bucket names are public, so please do not include any confidential information in the bucket names. Different buckets can have objects with the same name. If possible, consider storing small files as bigger units. If you know that some set of files will be used together, then store them as one object. Please be aware that, as with buckets, existing objects cannot be directly renamed. This means information you have described in a folder structure can be lost. This is again another reason to try to create unique file names. When you move data from an object storage to another system, you need to take into account that there is no directory hierarchy inside a bucket, even though interfaces often try to mimic file system-like hierarchy. Thank you for watching. We hope this was a helpful introduction to managing files and file naming, and why it's important for keeping your data findable and in order. Next time we will talk about file integrity and checksums.